Hello student, and today going to present the share force and bending moment on simple problem on overhanging beam. In previous class we have already discussed about the different type of problem in overhanging beams, and today we also going to discuss an overhanging beams in the more complicated problem in the previous ones. So let's see how can we solve the overhanging beams problems. So we know that what is overhanging beams. If the beam is supported in simple supported in the extended part of the beams is known as the overhanging beams. So we have know that what is overhanging beams. So let start how can we solve the problem on the overhanging beams. Let's see, here we can see that it is a overhanging beams, and it is overhanging beams, and here we can see that one supported at point B and another support at point. Here you can take this point in the end point in support at R2, and UDL over the beam is 200 kg per meters and 1000 kg load at point airs, and another 600 kg load at the free end. And distance of the beam is equal to how much? And distance of the beam is equal to 2 meter plus 3 plus 2, that means 7 meter. So let's start how can we solve this type of problem in overhanging beams. So first of all, to know that when we find out the sfd and bmd, we write here the uh, reactions and find out the reactions r1 and r2. So here we can see that the r1 and r2 is equal to total load is equal to how much? As we know that 6 kg and 1000 kg, that means 16,000, and udls 200 kg per meter, that means 2, that means 4, that means 600,016 plus 4, that means 2000 kg total load. It is equation number 1. Now we need to another equation to find out the r and r2. Then taking a moment about point A, now take a moment, taking a moment about point D. That means we take a moment from this point A, B, C. We take a point from this one. So we take a 1 over point this. So now let's write how can I write the moments. So you see the figure. You take a 1 over point D. So R means R2 into how much distance? R2 means R2 into distance 7. So we can here write R2 into 7. R2 into 7 equal to another load this point. Sorry, we take a one about point this, that means R1 point to R2, sorry, R1 minus R1 into 5. Sorry, this one is actually R1, not R1 R2. This is actually R1 into 5. So R1 into 5. Then 1000 into 2, 1000 into 2, again UDL 400 into 1 because of middle, we know that, plus 400 into 1 plus another load. You can see that this load 6. That means 600 into 7. 100 into 7. So how much? This one is equal to 2000 plus 400 plus 42. This one is equal to how much? That means 4200 plus 400 plus 200. That means 6600. 6600. Then R1 equal to 6600 divided by 5. 1320. That is the value of R1. Then we can easily find out the R2. What is the R2? Then R2 is equal to, you know that R2 is equal to, we already find out the value of R1 plus R to R2 is equal to 200 minus 2000 minus R1. 2000 minus of R1. That means 2000 minus of 1320. That means how much? That means 2000. You can easily calculate this value 680. So value of 680. So we can easily find out the R1 and R2. After that, find out the shear force and different point, then find out the bending moment and draw the sfd and bmd. So for shear force, SF at, you can see the figure, SF at point, to find SF at point A, SF at point B, SF at point C, and SF at point D. So find out SF at A and B and C and then D. So SF at point C, A, I can easily find out minus 600 downward directions. So equal to minus 600 downward directions, and kg force, all right, the kg. Then SF at B, SF at B is equal to minus 6, and at B is equal to how much? You can see the figure. B is equal to, in upward directions, R1. The value of R1 already find out. What is the value of R1? Is 1320. So this one not a minus, actually 1320. Then let's calculate the value. 1320 320 minus of 600 is equal to how much? 720. So 7. So you can write here 720. Then find out the, already find out the B value. Then find out the C. Before going to find out the point C, so we can easily find out the C. So how can the value of C? Value find out the C. C point C. SF at C is equal to plus minus of 1000 because of downward directions. So this one is equal to how much? 1000 minus 720. 1000 minus 720 is equal to how much? 280, because of minus 280. Then SF at SF at not actually at just before D because of two combined load. One is SF just before D minus 2 plus of UDL. UDL is equal to how much? You can see that UDL is equal to how much? And intensity of UDL is equal to 200 kg per meter. That means length 2 into 2 into 4. That means 400. So 400. Then plus of 400 minus 280 is equal to how much? 120. That means 120 SF at just before D. So let's check start. Before going to let's check again. Then find out the SF different value. Then 5 R1 is equal to 5. Then 600 into 7. R1 is equal to 200. 600 R2 is equal to 680. SF at 637. So plus 7,000 minus D also downward directions, not actually plus. This is a minus sign. That means this value is to correct here. So because of downward directions, so this one is equal to 680. 680. So already find out the value of R2 680 here. So R2 and R1 is the same, but the direction is different because of the moment. Then find out the VM at different point. For BM at point A is equal to how much? So we find out the BM at point this one is equal to 0. So BM point is 0. Again find out the BM at point B. BM at point B is equal to how much? Minus of load into distance, perpendicular distance. Then load is equal to how much? 600 into 2. 600 into 2. That means minus 12 kg into meter. You need to know that moment length force in particular distance. Then C point C is equal to how much? Again take a C. 600 into 5 and R value of R1 into 3. 600 into 5. 600 into 5. 600 into 5 minus of R1. Value of R1 will only find out. Then value of R1 is equal to 1320 into 3 plus upward direction plus 1320 into 3. Then we can easily calculate this one is equal to how much? That means 300. That means 1320 into 3 . minus of 96919 kg into meter, kg into meter, kg into meter. Then Bm at point D is equal to 0. Then Bm at C, we know that if I find out the Bm at the and C, then Bm point D, when we find out the Bm at point D, we know that find the Bm at the find out the any fixed point equal to, we know that 0. So we can easily write out the 0, or you can calculate, and you calculate the Bm at point D, so we can get the value of 0 also. So no need to calculate, we can write here directly at point D is equal to 0, as we know that. So we have already find out the Bm at different point, and also find out the shear force at the different point. Now draw the SFD and BMD. Before going to draw the SFD and BMD, you know that you need to draw the uh, you need to draw the loaded beam. Then after that draw the SFD and the BMD. So let's see how can I draw the SFD and BMD diagram. So let's see. So first to draw the loaded beam. And let's see how can I draw the SFD and BMD. Now here it is the loaded beam. It is the point D. We know that. Right on the D. Then draw the straight line from every point. Then we can easily draw the SFD and the BMD. Then take a reference line and draw the first of all draw the SFD diagram. So how can I draw the SFD diagram? SF and diagram. Let's see. The value of SF at point A, we know that is 600. So draw a straight line from this point. So this point to this point, as we know that suppose there is a 600. Is a minus 600. This line. You can take any scale according to your convenient. So and as a point A, as a point B is equal to how much? SF at point B, SF point B is plus 720. That means no load between the A and B. So this line is straight line. This line is straight line from here to here, and again straight line from here. This point is the how much? 720. This point is 720. Positive 720. And again, no load between the B and C. Here we can see that. So this one also straight line. Then how much value up at point C? So let's see the SFBM as a point C is equal to minus of 28 to 80. Then again take a straight line from this point and this one is 28. So this one value is the minus 280 at point C. And as the UDL load, then just before D is equal to how much? We know that just before D only find out, just before D is equal to here, just before D is equal to also minus 68, and SFD BUs already find out 680 minus because of due to minus sign, negative sign. So minus 68. So we can here take the right, take a straight line from here to here is this one, minus 68. So with the minus of 68. So this is the diagram of the SFD. This diagram, this is the curve diagram. Is called the SF diagram. SFD. Similar, we can draw the BMD also. Let's see how can draw the BMD diagram. So I will draw the BMD. Here you can see that draw a straight line, reference, draw a reference line here, and as you're convenient, you can take a straight line at every point, take a straight line from the this point also be, and a reference line. Already we take a reference line here. Now draw. We know that the BM at already find out the different point. B at point A is equal to 0 and B at D is equal to 0. Then B and C, B and C is minus 1200, 0. That means here 0. Here we can see that. So 0 here and B is minus 12. So we can draw a direct straight line. Here, straight line, and point D, C is plus, then C is plus. Also, this one is the plus, and also after D is 0. Then here load is UDL, here draw is the curve line because of C and D is the, it is the parabolic nature. This curve is parabolic. This line is a straight line. This is the BMD for this loaded beam. This was the BMD. Why this curve line? Because of this portions B, C, and D. This is the load beam is the UDL load. That's why this diagram is the curve, means parabolic. But here no, it's a point load. That's why the straight line. This is the calculated beam diagram for the field, this type of loaded beam. I think you understand what I am trying to, what I am actually trying to solve SFD and BMD. Then so it is a clear cut idea for the overhanging beam of the SFD and BMD. So thank you very much for watching this video, and any clarifications then contact me, as you know that. So thank you very much.